Sky at Night with Patrick Moore.
Good evening. First, the comet, Comet Hale-Bopp, a truly magnificent comet, now well on view. And you'll see it in the evening sky. Look in the northwest after sunset, and you can't possibly miss it. That was the position on March the 11th. There was a position on March 21st. And it's moving north near Cassiopeia, and then it'll be visible all night. And it's brighter than most of the stars, with a blurred head and long, gleaming tails. We've got some pictures of it. Here's a lovely view by Douglas Arnold. Note there the two tails. And here's another Douglas Arnold picture. You can see there the gas tail over to the left and the dust tail. And from Scotland, Jack Cooper sent us this rather scenic picture. And from America, this lovely picture by Kent Blackwell. And that shows the colours very well. There is the curved dust tail, rather brownish, and the long gas or ion tail is blue, as you can see. Well, let me assure you, the comet's not close to us. It won't come much within 130 million miles of us, so it's further away from us than the sun is. But it is a very big comet. The nucleus is probably 25 miles across, which by cometary standards is huge, and the tails, of course, are millions of miles long. So make the most of it. It's going to be visible now, well on view, for the next few weeks. Do you remember SOHO, the Solar and Heliospheric Observatory? That is sending back superb pictures of the sun. First of all, the sun in Sagittarius. You can see there the star clouds in Sagittarius to the bottom of the picture. And at about 7 o'clock to the sun, you can see a comet. And that is a doomed comet. It's going in toward the sun. It did go in, and it never came out. And the sun at the moment is highly active, as you can see, puffing off material. And so actually obtained lovely pictures of a whole cloud of material being ejected from the sun. These are possibly the best solar pictures ever obtained. But now, on to our main theme. Have you ever heard of the Zodiacal Light? It's a faint, cone-shaped glow rising either from the western horizon after sunset or the eastern horizon before dawn. Not very easy to see, but in point of fact, there's a good time coming now for the 10 days after about March the 26th, when the moon is out of the way. You know, in the whole of the 40 years we've been doing the Sky at Night, we've never devoted a whole program to the Zodiacal Light. And so now we're going to do so. And I'm delighted to welcome an expert on the subject, Dr. John James from Manchester University. Welcome to the Sky at Night, John.
Good evening, Patrick.
First of all, what exactly does the Zodiacal Light look like?
It's a great tapering shaft of light which you can see in the western sky after the end of twilight. And it's about as bright as the Milky Way, leaning over towards the south, but it's a softer, more ghostly appearance than the Milky Way, without the dark lanes and streaks that you see. In England it always leans over to the south, but in the tropics you can see it standing vertical at the western horizon. With a sensitive CCD camera, photographs can be taken. This is a typical one of the morning zodiacal light, in fact, but showing it standing vertical. There is a sequence of photographs here of the zodiacal light during the evening, fading gradually as it sets, as the Earth rotates, of course, and it's all disappeared by about 10:30 in the evening.
What exactly causes it?
There's a great cloud of dust in the solar system, very flattened, lens-shaped or discus-shaped, with the sun at the center and lying in the ecliptic plane. That is the plane which contains the planets and their orbits. And this ecliptic plane is tilted at 23.5 degrees to the equator of the Earth. So we never see the zodiacal light on the equator, but on the ecliptic great circle on the sky. And here you see the effect that the Earth has its equator, pole star above, of course, and the ecliptic is tilted at this 23 degrees. On March the 21st, at the spring equinox, the sun is also on the equator, and 3 months later, since the sun moves around 1 degree a day, on June the 21st, it is at the solstice and is highest in the sky. 3 months later again, it's back at the autumnal equinox, and another 3 months later it's at the winter solstice and it's at its lowest in the sky. Now, if you're standing on Earth, you can get the effect. Somebody standing in the field will see the whole of the celestial sphere tilted in this way, the equator above the Earth's equator and the ecliptic here shown tilted. And on March the 21st, the sun is just below the horizon, and there is the zodiacal light. It is dust reflecting sunlight and stretched out along the ecliptic. Now, at the equinox, the sun is on the equator, and after it has set in the west, you will see Mercury in the evening twilight, and you will see the zodiacal light stretching up towards the south, passing north of Betelgeuse and south of Capella until it disappears into the Milky Way just to the west of Orion.
It's been known for a long time, hasn't it?
Oh yes, it's been known since ancient times and appears in old Arabic astronomical manuscripts. It was important in Islam, of course, because of the instruction to pray at dawn, and could easily be confused with the beginning of the morning twilight. And it appears in these manuscripts under various names. It's the false dawn, yes. It is the wolf's tail, it is dawn's left hand. Yes. It appears in the Rubaiyat of Omar Khayyam, in fact. There is a verse which in the Fitzgerald translation begins, dreaming when dawn's left hand is in the sky, I heard a voice within the tavern cry, and so on. But in European literature it appears, of all places, in Shakespeare. And there's a scene in Romeo and Juliet. It's Act 3, Scene 5. It's the morning after the wedding night, and Romeo has to leave town in a hurry. He's wanted for murder. And he's saying, night's candles are burned out, and jocund day stands tiptoe on the misty mountaintop. And Juliet replies, and this is the line that matters, yon is not daylight, I know it, it is some meteor which the sun exhales. And this is very prescient. But in modern times, oh no, there was Cassini, of course, first. Yes, Cassini was the first scientist, actually, to describe it. And he described it in the Journal des Savants in 1683. And he mentions it as not being in the sphere of Earth, but in being in one of the upper spheres. In other words, it's a dust cloud around the sun, not something in Earth's atmosphere.
Another lovely drawing by him.
This is a remarkable drawing by Cassini, which appears with his article, and it shows the zodiacal light passing through the various constellations, beautifully drawn there, of course.
What about modern studies?
In modern times, the great classic study was by Professor Blackwell and Dr. Ingham and their associates in the 1950s, and they measured the intensity, and they showed for the first time that it was definitely in interplanetary space and not something circling the Earth. It was Dr. Ingham, in fact, who took the first spectrum and showed that essentially it is the spectrum of sunlight.
Well, I gather you've been making your own spectroscopic observations of it.
Yes. As you know, the spectrum of sunlight is crossed by many dark lines, the so-called Fraunhofer lines, because some of the wavelengths are missing. Now, when the sunlight is scattered from the dust, because the dust itself is moving, we see small Doppler shifts, either to the red or to the blue. And if we look in the morning when the dust is moving away from us, we see a red shift, and if we look in the evening, there is a blue shift. And I've been with my Japanese colleague, Professor Mukai of Kobe University, on a high mountain in the tropics, making these measurements both in the evening and the morning light. It's a very delicate measurement because the shift is very, very small indeed. And we've discovered that the dust is all going around in the same direction, but that the speed is very much less than we'd expected. Now, we don't know why this is yet.
What have these investigations told you?
Well, as well as the spectroscopic observations, we've been taking very accurate photometric pictures of the zodiacal light, of which this is a sequence of it rising in the morning, getting brighter. The sun is well below the horizon still. This is the last of the sequence, which shows just dawn approaching. And this has told us a great deal about the structure of the cloud, because drawing isophots, that is contours of equal brightness, you can see that there are kinks to the right-hand side, that is to the southern side, and these we think are because of belts of dust which are going around the sun on their own account somewhere near the asteroid belt. But the most unexpected thing of all was that the whole of the cloud is tilted to the south. And here is a picture which I found in my archives, sent to me 30 years ago by an Argentinian astronomer, taken at the same time of year, looking in the opposite direction, and behold, it's tilted to the north. So the whole of the dust cloud is tilted with respect to the solar system. And again, we don't understand why this is.
It's extraordinary. Do observations from satellites tell you anything?
Yes, they complement the sort of measurements that we make. Here's the IRAS satellite, for example, which measures not the scattered sunlight, but the actual thermal and infrared emission of the dust itself. And here's a photograph which shows the zodiacal light taken by the IRAS. And this has told us a great deal about the nature of the dust particles, the fact that they are solid lumps rather than fluffy. Here's another photograph which shows the galaxy, in fact, and the blue streak which you see going from about 7 o'clock and up to 1 o'clock is, in fact, the zodiacal light itself. And this is Kobe, a more recent satellite, And this has found the same sort of dust belts we have found with our photographs, but apparently these are right out in the asteroid belt, and the reason for them yet still unknown.
Have you come to any firm conclusions about the origin of the zodiacal light particles?
We're coming to the conclusion that the dust particles, because of the nature of their infrared emission, are the result of asteroids meeting each other, colliding, breaking up, and not, as we had previously thought, the result of comets evaporating their dust as they come close to the sun. Obviously there is a cometary contribution, which you can see in the sky at the present time, but most of the dust appears to be the result of asteroids colliding violently and spraying dust all over the inside of the solar system.
Is there any connection between zodiacal light particles and larger impactors, such as meteorites?
Well, the word impactors makes me slightly nervous, of course, but that's what they are. And in fact, there's a whole range of sizes, quite continuous range of sizes, right down from the minor planets, down through the meteorites, which we sometimes see in the sky, through smaller meteorites, which we don't see, but which still can be detected by radar, right down to the very finest particles about a thousandth of a millimeter in diameter, and it's these very small particles which form the zodiacal light.
There's an even fainter patch of light in the sky, exactly opposite to the sun, only seen under very favourable conditions. The German name for it is Gegenschein. We call it the counterglow. And you know, I must admit, I've seen it only once in my life, and that was way back in 1943, when the entire country was blacked out as a precaution against German air raids, and the sky was pleasingly dark. And I did see it then, never since. Well, what exactly is it, and where do you look for it?
Well, you're quite right. Of course, it is exceedingly faint, and for most people, you require the eye of faith to see it. But in fact, we have photographed it, and here is a picture which we took at the same time as our other photographs, showing it almost, but not quite, exactly opposite to the sun. It's a patch of light about 5 or 6 degrees in diameter. It should be on the ecliptic, where the sun is going to be in 6 months' time. In fact, it's about 2 degrees south of the ecliptic. The reason for this, we don't know. One possibility is that it comes from dust which lies in the asteroid belt. The Earth lies on the ecliptic, but there is another plane, the average plane of the solar system, known as the invariable plane, the average sort of plane where all the planet orbits lie. And this is tilted about 1.5 degrees to the Earth's orbit. And if you draw a line from Earth to the Gegenschein, to where you see it on the sky, that line intercepts the invariable plane just in the asteroid belt. And this leads me to think that the light that we see, the Gegenschein light, is in fact sunlight scattered by dust in the asteroid belt.
Now for the vital question, John. Where and when do we look for the zodiacal light and the Gegenschein in the immediate future?
It's not easy. The best place to be is on the western coast of Devon or Cornwall, or possibly the Scilly Islands, or possibly South Wales. You need to wait until 1 3/4 hours after sunset, because you must be sure that the twilight has ended. You also must have your eyes dark adapted. Now this means sitting in a darkened room for about 20 minutes so that you get proper night vision. Then you will see it. Somewhat to the north of west, rising from the horizon, leaning over towards the south, the left that is, and passing upwards between Aldebaran and Capella, north of Betelgeuse, and disappearing into the Milky Way somewhere about Pollux and Castor.
I gather it's very difficult indeed to record the Gegenschein with an ordinary camera, but of course the zodiacal light is different. Can you photograph the zodiacal light easily?
Yes, you need to have a proper camera. You need, for example, to have a good focal ratio, f3.5 or less, and you should have a wide-angle lens, say 35 millimeters focal length or less. And you need a tripod, and you should have a cable release, because you're going to take time exposures. And you set the camera up facing west, with the long side of the frame perpendicular to the horizon, and with the horizon just at the bottom of the frame. And you wait until 1 3/4 hours after sunset, otherwise you risk twilight, and you take exposures of about 5 or 10 minutes. And you need a fast film, of course, 400 ASA. And if possible, you should get the film developed the same night or at latest the following day, because these faint images fade rather quickly.
You've got some good photographs of your own, haven't you?
Oh yes, this is one which I took in the Canary Islands with Kohoutek's comet in fact in it, and that is Jupiter in the middle of the zodiacal light. But since then I've been photographing with colour film, and The Zodiacal Light shows with different types of film in different colors, but this is the evening Zodiacal Light again. And here's another one, slightly fainter. This is really what it looks like. This is an excellent photograph of the Zodiacal Light that you're going to see when you look. This is the best photograph which I took of the subject.
Of course, here in Britain, light pollution is a constant hazard, but it's better, things are better from a country where there's less light pollution and clearer skies.
Oh yes, it is an unmitigated curse. The light pollution is ruining astronomy all over Europe. The best thing to do is to take a holiday in Tenerife or the West Indies. If you're lucky enough to go to Tenerife, you should hire a car and drive up into the crater, because a couple of hours after sunset you will see the most magnificent display of stars, and of course you will see the Zodiacal Light.
Well, I was in the Canary Islands some time ago, and at a high altitude by the observatory there, and I took a couple of pictures of the Zodiacal Light, and there is one, and you can see the Zodiacal Light quite easily, and it did look rather like that. So at that stage, I got ambitious, and I decided to take a longer exposure with a faster lens, and the result was that. And of course, that really does look rather nice, I think, but at the same time, it's far brighter than it actually appeared in the sky.
That's right. The first of the two was a remarkably good and accurate picture.
Certainly, the Zodiacal Light is by no means obtrusive, but it's always worth looking for. And there's something very fascinating when you actually see this faint, ethereal, rather ghostly light in the sky. John, thank you very much.
My pleasure.
Now, don't forget, if you want the latest astronomical information, then you dial up the Sky Night information line, 0891 800 030, or of course CFAX, page 620. And don't forget now, it's newsletter time. So if you want your newsletter, then as usual, send your stamped addressed envelope to newsletter number 65, The Sky at Night, BBC TV, London W12 7TS. Our next programme is going to be on April the 27th, and rather a special programme. This is our 40th anniversary. Our first Sky at Night was broadcast in April 1957, and we were ushered in with a comet. Comet Aran-Roland, there it is, with the so-called reverse tail, which isn't really a tail at all, but merely material in the comet's orbit being illuminated by the sunlight at a special angle. And, of course, our 40th anniversary is being ushered in by an even brighter comet, Hale-Bopp. And don't forget Hale-Bopp, it really is a splendid sight now in the evening sky. Our programmes are going to be Eyes on the Universe, the story of the telescope, right the way from Galileo to the modern telescopes, such as the Hubble telescope and the Keck. And before I go, just one thing more. In the early morning of March the 24th, there's going to be an eclipse of the moon. When that happens, the moon passes into the shadow cast by the Earth, and since the moon shines entirely by reflected sunlight, the supply of direct sunlight is cut off, and the moon turns a dim, often coppery colour before it passes out of the shadow again. This is not a total eclipse, it's a large partial. More than 80% of the moon is going to be covered, so it begins about 3 o'clock in the morning and goes on until 6 o'clock in the morning. I'm not going to say that lunar eclipses are important. Frankly, they're not, but they are lovely to watch because they provide splendid opportunities for astronomical photography. So don't forget the eclipse of the moon, and please don't forget our special Sky at Night 40th anniversary, Eyes on the Universe, next April 27th. So until then, good night.